Morning to everyone. I'm Gayatri, working as a professor in Sri Vishnu Engineering College for Women. Okay, today I'm going to discuss about the difference between DFA and NFA. So you already know these are the two types of finite automators. Okay, let's see what is the main differences in between DFA and NFA. So what is the meaning of DFA means that is the deterministic finite automata, deterministic finite automata. Okay, and what about NFA means non-deterministic finite automata, non-deterministic finite automata. Okay, so now we see the what is the mathematical definition of the. So these are the two automatas, right? That is the one in the DFA and second one is the NFA. So now what is the mathematical definition of means? It is a mission. So we can represent with single thing. Okay. So with using five tuples, we can represent this amount, whether it is the DFA or NFA. So what are the tuples means? Q. Okay. So what is the meaning of the Q means? Set of all states. And next one is the input alphabet. And third one is the transition function. And the fourth one is the Q. That is the meaning of the initial state. And next one is the final state. Okay. So now we see the what is the meaning of the Q. Q means set of all states. So I will explain with example later. Next one is the input alphabet. So what are the inputs we are using in the automata? Input alphabet, correct? And this one is the transition function. So what is the meaning of the means? One state, what is the Q here? State, right? And what is the meaning of this one is input alphabet. State within some input alphabet. It can go to the only another state. That is one. Okay. Once again, see what is the definition of this one means state with some input alphabet, then it can move to the another state. Only one state only it can move, no more than one states. The next one is the initial state. Q naught is the initial state. Okay. And next one F is the final state. This is the final state, right? So these are the five tuples we can represent it using the these five tuples are used for representing the DFA. Same thing, what are the things are there in NFA means we can represent the symbol here. The same five tuples we are using, yes, and the initial state and F is the final state. Same set of all state, input alphabet. So only the difference is the transition function. So here what is the definition of the transition function is here also state readings and input alphabet, it can go to the more than one state. That means power of Q. Can write as the power of Q. But here see only one state only it can. Okay. That means after one state with reading some input symbol, it can go to the only one state only. But here in NFA, if one state reading some input symbol, it can go to the more than one state. That is only the main difference in between the DFA and NFA. The remaining tuples are the Q naught is the initial state and F is the final state. Okay, right? So this is the main difference. Okay. And next thing is, what is the next difference is here, the state has to consume all the inputs. Okay, that means has to read all the input symbols. That is one thing. But here NFA is not like that. So we'll see the one example. See, for example, if it is a DFA, okay, we'll see the one automata. Here it is the initial state Q naught and reading 0, it can move to the Q1 and okay, for example, here input alphabet is 0, 1. That means all state has to read all the input symbols in DFA. Okay, so see here, Q not read the 0 and it has to read the 1 also. And now it is moving to the Q2 something. And Q2, it is reading 1, then it is moving to the Q naught and reading 0. It is moved to the Q2. And what about Q2 means reading 0, it is moving to the Q naught and reading 1, it can move to the Q2. Okay, so now it is automated. Now how to check that whether the given automata is in the DFA or not? So here see, we in the previous we explained we represent with the five topics, right? So now first one is the Q, that is the set of all states, right? So what are the states we are having? Q naught, Q1, and Q2. Okay, so here Q2 is the final state. See here, initial state we can represent like this, and final state we can represent with the double circle like this. Initial state like this, and final state like that we can represent. These are the states, and next one is input alphabet. So what are the input alphabet? And is G in this example 0 and 1. Okay, so now we can write the transition function. So what is the definition previously explained? State input alphabet that it can move to the some other state, right? So now we see the transition function. Now what are the states we are having? Q naught, Q1, and next one is the Q2. So what are the input alphabet? 0 and 1. Okay, so now see Q naught. You see in this diagram, Q naught reading 0 where it is moving Q1. Okay, right? So Q1 and Q naught 1. Q naught after reading 1, it is moving to the Q2, right? And the next one, Q1. See Q1 reading 0, it is moving to the Q2. And next Q1 reading 1, it is moving to the Q naught, right? Similarly, Q2 reading 0, it can move to the Q naught. And reading 1, it is moving to the Q2 only, right? Q naught and Q2. See here, this is only the definition. The main definition, state input alphabet, then it can move to the only one state only, no more than one state. That is the one difference. And the second difference is all the states has to consume all the inputs. All the inputs we have to consume. All the states has to consume all the inputs. That means each and every state has to read all the inputs in this. See here, we're reading, right? Both states were reading. For example, so I will explain one more thing. So here, for example, Q naught, and one more thing is the Q1. So reading 0, right? And 0, 1. So it is initial state and it is the final state, right? So now see here, what is input alphabet? 0, 1. Okay, what are the states we are having? Q naught to Q1. Now we see that whether the automata is in DFA or not. So we can draw the transition function. So what are the states we are having? Q naught, Q1. The input alphabet is the 0, 1. See Q naught reading 0, it is moving to the Q1. But what about Q naught after reading 1? There is no, that is the empty. Okay. And right. And see Q1 reading 0, it is moving to the Q1 only. Now it was not there in DF. Why? Because of this. What is that? Q naught will not consume the input 1. Only it is consume the input 0. Okay, that is the thing. For example, okay, I will tell the one more example also. See here, for example, so we'll give the one more state here. For example, I am taking the Q2. Okay, see, reading 0, it is moving to the Q1. Q1 reading 0, it is moving to the Q2 and Q1 also. Now see Q1 reading 0, one is the Q1 and another one is the Q2 also. That means more than one state it is moving, right? So now because of this reason, now our automata also was not there in the DF. So these are the main two things we have to check that for DFA. One is, what is the first one? All the states has to consume all the inputs. Okay, right? So here it is not consuming, it is not reading. Okay, right? And second thing is, state reading one input, it can move to the only one state. And that is only the definition of the this one. Okay, right? These are the two things for DFA. Okay, right? So now we'll see the example for NF. So for example, NFA. We can take the one automata Q naught, Q1, and I'm taking the Q2. So here it is reading 0. For example, my input alphabet is 0, 1. Okay, and here it is reading 0, and here also it is reading 0, right? And next Q2 reading 1, and here it is the final state. Okay. So now we'll see the transition point. Here first thing is the states. So what are the states? We are having Q naught, Q1, Q2. Okay, and what is the initial state here? Q naught is the initial state and Q2 final state. Now input alphabet is the, what is that? Q naught and Q1. That means what are the inputs we are using in this automata. Okay, right? So now we see the transition function, right? So what is this? That is the states. One is the Q naught, Q1, and the Q2. So what are the inputs we are having? 0, 1. See now Q naught reading 0. It is moving to the Q1. Q naught 1. No, empty. Q naught there is no 1 reading. And Q1 reading 0. It is moving to the Q1 and Q2 also. Okay. So what about Q1 1? No, no. Q2 0 empty. And Q2 1 is the Q2 only. Right? So here what is the transition function state? Input alphabet, then power of Q. The more than 1. That is only the meaning of this one. Okay. And here that is the first property of the NFA. And second property is all states no need to consume all the inputs. Yet second one is the no need to consume all the inputs. That is also the second the property of the NFA. Okay, right? So now I think you understand the main differences in between the what is that NFA and DFA. One more thing is here initial state we can represent like this and final state we can represent like this. Here Q naught is the initial state. What is the Q naught value? Here Q naught only. And the final state. What is the final state means Q. Okay. And in both NFA or DFA, we can maintain the more than one final state. For example, see in this automata only Q2 is the final state. If you want, you can take the, based on our condition, we can take the more than one initial state, but more than one final state. But initial state is the, either it is the NFA or DFA, we can take the only one initial state and we can maintain, if you want, you can maintain more than one final state. Okay. So once again, see, the main difference in between the DFA and NFA is one thing is after reading one input, okay, in DFA has to generate the only one state only. It has to move to the only one state only. That is a one difference. And second difference is all states in DFA, all states has to consume all the inputs. But in NFA, it's not like that. Okay, so after reading on input symbol, it can move to the more than one state. And next one is no need to consume all the input symbols. Okay, so I think you understand the main differences in between the NFA and DFA. Okay, thank you for